Ask you a question. Think about this. I want you to really think about this. Have you ever heard of survival of the fittest? Have you ever heard of that? Well, it's kind of a thing, but it's not necessarily the fittest, as in like one person or one individual or one species. It's really about how things actually change in the world. We have 2 notebook pages today. We are going to do kind of a lab, which is pretty fun. So when we do the lab, if you are virtual or unable to be present during the lab, please check the Learning Targets document to get data so that you can complete the lab. Okay, I'll talk to you more about that in just a minute. So our first learning target is, I understand that natural selection may lead to increases and decreases of specific traits over time. So you might have already been staring at these bugs. I have some cockroaches here. They're not alive, of course, but you can see them really easily. But they have some similarities and differences. So this cockroach has like hairy legs, right? You can see the little hairs on them. And this one has not so long hairs on the legs, and this one has like really short legs in the front. So a lot of times, traits are passed from one parent to another, and it's usually a trait that is dominant, and it is what shows up in the offspring. So like 2 parents get together and one offspring comes from that, and that particular offspring or child has characteristics that are dominant, that show up physically, okay? And those are called traits. So traits are inherited characteristics that appear in offspring. So trait. Say it with me, trait. The next term that we need to know is called natural selection. And this is an idea that there's a process through which populations of living organisms adapt and change. Now, humans, we adapt and change. It gets cold out, we put on a coat. It gets warm out, we put on a t-shirt or a bathing suit, whatever. We try and get cooler, right? Animals don't walk around and they're not like, oh, I need a coat today. Oh, I should wear my raincoat. Oh, I should wear my tennis shoes instead of my flip-flops. I'm going to need some mud boots. That doesn't happen, right? So they can't just decide to change. So it's usually this, oh, what is that on me? Do you see it? Oh my God. It was creepy crawling me. Oh. Oh, there's 2 of them there now with hairy legs. Isn't that interesting? You probably crawl on things really well. So that hairy-legged one might be able to get around a little bit better than the one with the short legs or the no hairs on the legs. Today, you're going to watch about how traits actually get passed from generation to generation, offspring to offspring, and you're going to see why this matters, okay? So you're going to read a bunch of different scenarios about like maybe why giraffes have long necks instead of short necks, or why elephants have long trunks instead of short trunks, or why some moths will live in some places and others won't. You get to pick one, or you can Google it and find another one if you want, and illustrate a scenario that leads to adaptation by natural selection. Okay? And I would also like you to include an explanation why a trait which helps an animal or plant live longer will become more common in the population. So let's say there's an area that is lush and green with life. Did you know that there is a cactus that grows in Michigan? It's called the prickly pear. Yeah, even though it gets cold here, the prickly pear is still a cactus, and it does grow in Michigan, outside no less. What? Yeah, some cactus can survive the cold. Most cactus cannot. So you wouldn't walk out the door and go outside and find a bunch of cactus here in Michigan, because they also don't need a lot of water. And so you can literally drown a cactus if you give it too much water. Yep, because it's really good at storing water. But if you give it too much, it will drown. But if you don't give other plants enough water, sometimes they get damaged. You're going to see some examples of these. The idea is that you want to live long enough, or the species needs at least one of its kind to live long enough to reproduce and make species, more of the species that can live long enough to reproduce to keep the species alive, right? Okay, so our last learning target for today is I can use math to support how natural selection affects individual probabilities of survival. Oh my gosh, you have been hearing lately like, you have a 1 in 10 chance of surviving this, right? Or there's a 20% chance that that race car will make it around the track 52 times without changing the tire, okay? So we're going to use math. Don't be afraid. It's not hard, and we're going to do it together. We're going to use math, look at adaptations, and find out what kinds of things give organisms a better chance at survival. So our key term for this page is adaptation. Say it with me, adaptation. It's the process by which a species becomes fitted to its environment. Now listen, a fish can't just decide to grow feet or grow lungs, but there might be a fish that grows bigger gills that can live in a pond that has less oxygen than another fish, right? And so that fish will live longer. All right, so let me show you something crazy. So if I do this, okay, you guys saw these, right? But if I do this, it's much harder to see them, right? Much harder to see them because they blend in. And camouflage is something that's really important for animals. Usually you can't see deer unless they make a motion or a movement, okay? Usually you don't see a rabbit unless it hops away, right? They stay real still, or their fur blends in, right? So camouflage is an adaptation. So if I made one of these striped and wanted to fit it on this paper, you probably wouldn't see it very well, okay? It's just kind of an idea. So what we're going to do today is I'm going to give you two moths. I'm going to give you one of just a plain bright color, and I'm going to give you one that you can hide in plain sight. The one that you can hide in plain sight, which means you have to see it. You both have to hide both in plain sight, like you have to be able to not move anything and be able to see it. So the first moth that I'm going to give you is a brighter color, okay? And you're just going to hide it anywhere in the room in plain sight. The second one is white. You're going to have to color it so it kind of blends in to its surroundings, okay? And then, in a little while, a predator is going to enter our room, and it's going to eat all the moths it can find. We're going to give the predator 30 seconds. Now, this predator has really good sharp eyes because all it does all day is hunt for moths, okay? So we're going to look at the total population of the moths that we start with. Everybody will have two that are one that's camouflaged and one that's a bright color. We'll figure out how many survived, and then we'll figure out what the percentage is of how many of them survived. So like, do you have a 50% chance of survival if a predator comes in the room? We're going to find out today. Again, if you don't do this actual activity in person, please look at the learning targets and get some data there, and then you'll have to figure out your percentage of survivors. So if you have 10 as your total survivors, or you start with 10, and you have 5 that survive, you have 50% survivors. If you have 4 that you start with, and all 4 survive, then you have a 100% survival rate, okay? So I want you to make sure that you get the percentage right, okay? It's just the number of survivors divided by the total population. And then I want you to answer these questions. How does the color of a moth increase or decrease chance of survival? Then I want you to use your moth that you designed to explain natural selection. If you didn't design a moth, imagine if you did, and then use the number, okay? If there were no predators, would the moth color change? You need to be prepared to defend your answer, and you need to write it here. Then you're going to take a picture of notebook page 97. This is the last notebook page I'm going to ask you to submit. Take a picture of it and submit it. And that ends our lesson today. All right, good luck with your chances of survival.